Alrighty, so what electric field in what direction would make the particle go straight down the page? So let's draw a picture of this particle. We, by the way, know that it's a positive particle. It's going straight down the page. Remember that there's from the previous problem, it's 1.21 Tesla magnetic field out of the page. So let's draw a picture of that. It takes a while to make a magnetic field, right? It's just as well. All right, so here's this thing going down the page. Remember that the magnetic force is this way, right? I know that because I put my index finger here, right? My middle finger is out of the page, right? And so my thumb is pointing to the left when I do this, okay? So I know that that's the magnetic force. Now to make it go straight down the page, I have to have an equal electric force, right? And you get the electric force from E is F over Q, right? And so F, electric force, is EQ. This is, by the way, the electrical equivalent of force is mg, right? This is for gravity, this is for electric field. But anyway, okay, so now we're set. What we do is we say the electric force equals the magnetic force, which is QVB, and then it would go straight down the page. So QVB is equal to EQ. As long as you have a charge, as long as you're not dividing by zero here, this is well defined, right? So VB is E, and then, hey, we can just plug it in. Okay. Oh, golly, how fast was that thing going? It was like 2.96 times 10 to the 6th meters per second. Yeah. That's the velocity from the previous problem, right? The magnetic field is 1.21 Teslas, and then let's just multiply that 2.96 times 1.21 is 358.1600 newtons per coulomb. So that's 3.58 times 10 to the 6th. Now let's see, which direction is it? Well, this is easy. This is a positive charge. We want the force to be to the right. So this electric field would be to the right. Okay? So what I always say to do is to draw a picture of it in the previous problem with it going in the direction of this problem. Right? So just read the next problem when you get to like problem 4, right? Read problem 5. Draw a picture of it going in the direction that problem 5 says. Figure out the direction of the magnetic force. The electric force should be exactly counter to that. Or you could invent some sort of new right-hand rule that tells you which way the crossed field is, right? It's got to be something like that. A velocity. I wonder, let's figure this out. Let's see, velocity is that way. It's right-hand rule. Oh, yeah, you could use your left hand. You could do V, you could do, oh yeah, that works. Looks like the electric field is in the direction of B cross V. Don't quote me on that. I'll test that on the next one. All right, good enough.